you need to be able to look at a chemical formula and decide what type of attractive forces that compound will have. The first one is a hydrocarbon. This one has carbon and hydrogen only, and so all of its bonds are nonpolar. So the whole molecule overall is nonpolar, and so that means that its attractive forces are just the dispersion. Dispersion are the attractions that any atoms have to each other, where the electron cloud gets slightly off center. Okay, next we have a compound that shows this OH. So the way that this is written, it shows you that it has a bond from oxygen to hydrogen. Notice that we could have written this with the hydrogen over here and just had C3H8. But because we write it with the OH, you can tell that there's an oxygen that has a hydrogen on it. And so since it has that, that means it can hydrogen bond. Okay, so these are the attractive forces, these that we're asked for. Okay, the last one, it does have an oxygen. So it has a polar bond in there somewhere, but it doesn't have O to H. These hydrogens are not attached to the oxygen. The oxygen must be attached to the carbon. So it does have a polar bond because oxygen is very electronegative. And since it's polar, it will form dipole-dipole attractions. Sometimes we just say dipole instead of saying it twice. From the strength of the attractive forces, we can make predictions of these different properties. And so what you just have to think about is the stronger the attractive force, the more stuck together the atoms or molecules are. And so you have to kind of look at what's happening in each type of attraction or each type of property. So in other words, boiling point. If you have a liquid and the molecules are stuck to each other and they're really stuck tightly, then you have to really heat them up, get them moving fast before they'll separate into a gas. So a compound with stronger attractive forces will have a higher boiling point. You have to really heat them to get them to separate. Surface tension has to do with the molecules being attracted to each other. And so if you have a stronger attractive forces, then you'll have a higher surface tension. These last two are kind of the opposite of the boiling point. Vapor pressure, basically these two are about the same thing. It's how easily does it evaporate? How easily does the liquid become the gas? And so if they're strongly attracted to each other, it's going to have a lower vapor pressure and lower volatility.